Assalamu alaikum everyone. Today I am excited to present our research project. The title is Pattern in Temperature Variations in Bangladesh, a group-based trajectory modeling approach. Firstly, a big thanks to our supervisor, co-supervisor and other teachers who supported us on this journey. Special gratitude to my teammate Mohammad Maniruzzaman for his invaluable assistance. I am Mohammad Shihab Sharar and I am eager to guide you through our project. Here is our plan for today. Let's dive into details. The discussion outlines a research study focused on the analysis of temperature trajectories in Bangladesh, highlighting the crucial role of temperature variation in influencing sectors like agriculture, ecology, and public health. Traditional analytical methods face challenges in capturing the complexity of temperature trends from diverse weather datasets, which require advanced statistical tools. Group-based trajectory modeling, in short GBTM, emerges as a powerful solution, allowing the identification of distinct temperature trajectory groups for a precise understanding of change over time. These are some literatures where they work on longitudinal data in various fields, like in criminology and clinical research. And in the last two literature, the author worked with temperature data, but none explored temperature variation in climate. So we set out to analyze Bangladesh temperature, identifying regions with similar trends. So these are our objectives. The first and second objective indicates identification of trajectory patterns across weather stations, also their consistency. And the third one is to characterize the group difference of those stations, and our fourth objective is to compare those trajectory groups shapes. Now let's talk about our research methodology. This part will cover how we process data and the method we used for our project. These 5 points represent our workflow, what we did throughout our project progression. Important mention is that our study population is the temperature variation of 35 weather stations of Bangladesh. Our data is secondary, which we collected from BARC, and later we use many statistical tools including SAS 9.4 for application of group-based trajectory model. The picture is a geospatial representation of the weather stations of Bangladesh. We collected data on maximum and minimum temperature from 1980 to 2022, manually calculating temperature differences. There were some missing values, as you can see in this heat map. Through this heat map, we can visualize the missingness of our data, where the red color represents the missing data for those stations. So, before preprocessing, we had 733 missing observations, posing a challenge for our analysis. Due to SAS 9.4 limits and model complexity, we divided our dataset into two time periods, excluding the station name Ambagan. Now let's talk about the model we used, group-based trajectory model. Now, what is trajectory? A trajectory is defined as the curved path that an object follows after it's been thrown or shot in the air. The first animation is a glimpse of a trajectory. In the case of longitudinal data, a trajectory describes the evaluation of a quantity, behavior, or some other repeated measure of interest over time. This is the basic framework of GBTM. GBTM is one of the most frequently used approaches to identify subgroups of individuals in the longitudinal data. GBTM is an application of finite mixture modeling. It helps us to understand the evaluation of temperature over time. These formulas are the base of group-based trajectory model that calculate the unconditional probability and group membership. The goal is to find parameters that maximize the overall likelihood, giving the best fit. The posterior probability estimates the likelihood that an individual belongs to a certain group, and the last equation represents a regression equation, specifically a polynomial regression model that describes the trajectory shapes. For model selection, we need the BIC value. The model selection has two parts. It involves choosing the number of groups and then the best combination of shapes. To select the optimal number of groups, we have two methods. One is Jeffreys scale and another is logged bias factor. But both of them are difficult to calculate. So Kass and Wasserman suggest a different formula. To select the best trajectory group for the data using probability of model correctness. Now let's move on to the result and discussion. The tables provide information about the number of groups, trajectory shapes, BIC values for 34 stations, and the probability of model correctness for different number of trajectory groups. Based on the model selection that we discussed in our research methodology, from the first table using PJ criteria, we get 3 trajectory group is the best choice for the time frame from year 1992 to 2012. And from the right table, based on the significant p-value, we select the trajectory shapes for each group. Also, the table shows the calculated parameters for each group. So we get our best model that's suitable for the data, which is 3 trajectory group with linear, and quadratic for the third group. Now we will visualize the trajectory for 3 groups. The trajectories for each group are visualized in this picture, and the table shows the result of the wild test, confirming the trajectory group are significantly different. For a clearer view, the picture in the right corner displays trajectory mean values and confidence intervals, revealing distinct shapes for each group, where the trajectory group 1 is linearly increasing and the second one shows a decreasing trend, and the last group in the blue line shows a parabolic shape. This table displays information about different stations, their assigned groups, and the probability of belonging to each group. Each station is assigned to the group for which it has the highest probability. For example, station Vola has the highest probability in group 1, so is assigned to the group 1. We have created detailed tables for each trajectory group for better understanding. Group 1 has low temperature variation, while Group 3 shows high variation with a quadratic shape. In these maps of Bangladesh, we have highlighted each trajectory group members using distinct color. The red station represents Group 1, characterized by low temperature variation. The green station belongs to Group 2, indicating a moderate temperature variation. Lastly, The blue station signify Group 3, exhibiting high temperature variation explained by a quadratic. We repeated the analysis for year 2013 to 2022, finding two trajectory groups with quartic shapes, the best fitted model. Visualizations and inverse testing confirm that trajectories are significantly different for this time frame. The table shows the assigned groups and their probabilities for the second time frame. Here we have also created detailed table for each trajectory group for better understanding. Group 1 has low temperature variation, while Group 2 has high temperature variation. Each group represents quartic shapes. And here we highlight each group with their assigned color in the map of Bangladesh. Our study has limitation. Segmentation of time frames for handling missing data might overlook long-term trends. Interpreting trajectory group required additional context. SAS 9.4's character limit and inability to handle missing data pose challenges affecting the continuity of trajectory patterns. Despite this, our research offers valuable insight into Bangladesh temperature variation. Our journey into Bangladesh temperature patterns unveiled distinct trends using group-based trajectory modeling. Temporal variation from two time frames highlight the dynamic nature of temperatures. Validated accuracy and reliability emphasize practical implications. Future research focuses on refining predictive models, integrating spatial analysis, fostering cross-disciplinary collaboration, and validating findings in diverse contexts. This ongoing exploration promises valuable insight for agriculture, health risks anticipation, and effective public health planning. Our presentation has been shaped by the valuable insight provided by these references. Thank you for joining me today. Again, a big thanks to my supervisor, friends, and all of you. If you had any questions, do leave a comment. Science is a journey, and it's been great sharing this stuff with you. So keep exploring, learning, and making a difference. Shukran, and have a fantastic day.